Okay, Assalamualaikum everyone. I hope you all safe and still energetic to start our first lecture session this week. Okay, after we finished chapter 1 and chapter 2 in the last few weeks, so today we will learn about chapter 3, which is for chemical bonding and water. As usual, I have given you all the topics that we will cover in each chapter. So for this chapter, we have 4 topics with several subtopics. Okay. At the end of this chapter, make sure each of you should be able to identify the chemical bonds and molecules. Then you are able to determine the structure and properties of water and describe the aqueous solutions and buffering mechanisms. So now we move to the first topic about review on the structure and behavior of atoms. Okay, first one, what is atom? Okay, so for this one, I think it is not necessary for me to explain more about atom because I guess you have learned this in your chemistry class. So basically, you have to know that atom is the basic building blocks of ordinary matter or elements. And this atom must made up of protons, electrons, and neutrons. Okay, next, the charges of the electrons, protons, and neutrons. Of course, you have learned this one. The proton has the positive charge, which is located inside the nucleus. Next, neutron has neutral charge, and the electron, which is located outside of the nucleus, has a negative charge. I hope you all still remember and familiar with these 3 terms. Okay, the first term is atomic number. Atomic number is the number of proton or electron, or sometimes we use the term atomic number as proton number. Okay, second term is mass number. Mass number is the number of protons and neutrons, which means mass number is the number of protons plus number of neutrons. And the third term is neutron. So how you want to find the neutron number? It is the mass number minus number of protons. Okay, look at this example. So the example here use boron. Okay, so the value 5 above the B is the proton number or atomic number. Next, the value 11, which is below B, is the mass number. So when you have those values, mass number and atomic number or proton number, so you can find your neutron number. Okay, so how you want to find your neutrons? You have to take the mass number, which is 11, minus number of proton, which is 5, and then you will get 6, which is your neutron number. Electron, which is located outside of the nucleus, has their own shells, which we call as electron shells. Okay, so you have learned about these electron shells. And of course, the first electron shell can hold only 2 electrons. Okay, and each shell thereafter can hold up to 8 electrons. Okay, the example I will show you in the next slide. I take carbon as the example. So carbon has 6 atomic number. So as I said just now, the first electron shell, which is the innermost shell here, can hold only 2 electrons. And the shell thereafter, which is the outermost electron shell here, can hold up to 8 electrons. So when carbon has 6 atomic number, this means that 2 electrons are located in the first electron shell, which is the innermost shell. And the other 4 electrons are located in the outermost electron shell. Let's look at nitrogen, which has 7 atomic number. So those 2 electrons are presented in the innermost shell, and another 5 electrons are presented in the outermost shell. Same goes to oxygen, which has 8 atomic number. So 2 electrons are located in the innermost shell, and another 6 electrons are located in the outermost shell. Have you heard about octet rule? Okay, so octet rule is when the atoms tend to gain, lose, or share electrons so as to have 8 electrons. Next, what is elements? So elements are substances that cannot be broken down into simpler substances by chemical reactions. Of course, atom is the smallest portion of an element that retains its chemical properties. And then there are 4 elements are responsible for more than 96% of the mass of most organisms. Do you know what are they? So this question, I want you all to answer it in the tutorial class. Okay, isotopes are the elements with the same number of proton but different number of neutron. And of course, they have a different mass number. For example, these 2 isotopes, which are carbon-12 and carbon-14. So, what is the meaning of carbon-12? Carbon-12 is the most common isotope of carbon, which has 6 proton number and 12 as the value of atomic mass. Okay, so when you have your mass number and atomic number, you can find your neutron number, which is 6. And how about C14? C14 is a rare radioactive carbon isotope which has 14 mass number and 6 proton number. So you can calculate the neutron number here, which is 14 minus 6. You will get 8 neutron number for the C14, for the carbon 14. Okay, so these 2 examples shows you that isotopes have the same number of proton but have different number of neutrons. Next, we move to the second topic about chemical bonds and molecules. So make sure you still remember what are covalent bonds, ionic bonds, hydrogen bonds, and van der Waals forces. First, what is molecule? So molecule is when 2 or more atoms are held together by forces of attraction called chemical bond. For example, water molecule. Okay, one water molecule consists of 2 types of atoms, which are hydrogen and oxygen. Okay, so in this one molecule of water, there are 3 atoms held together, which has 1 oxygen atom and 2 hydrogen atoms. Okay, so those atoms held together we call as one molecule. Okay, so there are 2 types of molecular attraction, which are intramolecular forces and intermolecular force. Okay, so intramolecular forces are the forces that hold atoms or ions together within one molecule. For example, in one molecule of water, all the atoms, which are 2 hydrogen atoms and 1 oxygen atom, are held together by intramolecular forces. So those intramolecular forces can be covalent bond or ionic bond. Next, intermolecular forces hold molecules together, which means when one molecule of water attracted with another molecule of water. So those two molecules of water are attracted by the intermolecular forces. Okay, for example is hydrogen bonding. So please remember covalent bond and ionic bond are intramolecular forces, but for hydrogen bond is the intermolecular forces. Next, we look at the intramolecular bond or intramolecular forces. So just now you have learned that intramolecular force can be either covalent bond or ionic bond. First, we look at the covalent bond. Covalent bond is a bond between two atoms formed by sharing of electrons. So please highlight this. Covalent bonds is a bond between two atoms formed by sharing of electrons. So there are two types of covalent bonds, either nonpolar and polar bond. So nonpolar bond means equal sharing of electrons. But for polar bonding happens when unequal sharing of electrons which have positive and negative charge. Okay, what is nonpolar covalent bonding? So nonpolar covalent bond happens when two identical nonmetals equally share electrons between them. For example, chlorine share with another chlorine and hydrogen share electrons with another hydrogen atom. Polar covalent bond happens when electrons are shared unequally. As you can see here, the term polar. So polar means there are two different charges which are positive charge and negative charge. When one atom has greater electronegativity, therefore it has negative charge, and another atom has slightly positive charge. So these are the simplest examples of polar covalent bonds. Okay, so for sure polar has one atom which acts as negative charge and another atom which acts as positive charge. Next, we look at the second type of intramolecular force, which is ionic bond. So ionic bond is a bond between two ions which are formed from the transfer of electrons from one atom to another atom. So please remember that ionic bond happens when the transferring of electrons comes from metal atom to non-metal atom. For example, sodium chloride, which consists of sodium atom and chlorine atom. So sodium atom which is the metal atom, will transfer one of its electron to chlorine atom, which is non-metal. So when the sodium atom transfer its electron, it will become sodium ion, which is a cation or positive charge. And the chlorine atom, which receive or accept one electron, will become chloride ion, which is an anion or negative charge ion. Okay, another example of ionic bond is magnesium oxide. So this magnesium, which is metal atom, has two extra electrons and it will transfer its two electrons to the oxygen atom, which is non-metal atom. So this magnesium will loses two electrons and become positive charge, and the oxygen will gain two electrons and become the negative charge. Alright, next we look at the intermolecular forces. So this intermolecular force holding molecules together. Okay, for example, two molecules of water. So those two molecules of water are bonded or attracted by intermolecular force. Okay, so this intermolecular force is weaker than intramolecular force, which means hydrogen bond is weaker than covalent and ionic bond. So hydrogen bond is one of the intermolecular force. Hydrogen bond happens when it has a bonding between hydrogen atom to one of the highly electronegative atom. For example, when hydrogen atom bind to oxygen atom. So these two atoms are bonded by hydrogen bond. Same goes when the hydrogen bonded to fluorine atom. So this hydrogen and fluorine are bonded by the hydrogen bond. And the last is van der Waals forces. Van der Waals forces is a general term used to define the attraction of intermolecular forces between molecules. Okay, which means there is an interaction between oppositely charged region of polar molecules, or we call as dipoles. So dipoles here means it has two charge regions. Okay, it has positive and negative charge. So that positive and negative charge will attract each other. Okay, I will skip this slide, but make sure you all read this by your own. So please bear in mind that ionic bond, hydrogen bond, and van der Waals interaction are considered as weak bonds, and only covalent bond is considered as strong bond.